ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಎಲ್ಲರಿಗೂ ವೆಲ್ಕಮ್ ಬ್ಯಾಕ್ ಟು ಅವರ್ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ ಕ್ವಿಕ್ ಲರ್ನರ್ಸ್ ವಿತ್ ಸ್ಯಾಮ್ ಅಂಡ್ ಮುಶ್. ಸೊ ನಾವು ಇವತ್ತು ಯಾವ ಟಾಪಿಕ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಪ್ಪ ಅಂದರೆ ಹೈಯರ್ ಡೈಮೆನ್ಷನಲ್ ಸೆಗ್ಮೆಂಟ್ ಟ್ರೀಸ್. ಸೊ ಇದು ಟಾಪಿಕ್ ಒನ್ ಆಫ್ ದ ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಅಲ್ಲ. ಇದು ಎಲ್ ಬಿ ಏನತನ ಎಲ್ ಬಿ ಬಂದಿಲ್ಲ ಇದು ಟಾಪಿಕ್. ಇದು ಟಾಪಿಕ್ ನಿಮ್ಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮಿಗೆ ಬರ್ಬೋದು, ಮತ್ತು ನಿಮ್ದು ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಅಲ್ಲಿ ಬರ್ಬೋದು, ನಿಮ್ಮ ಡೇಟಾ ಸೆಕ್ಟರ್ ಅಲ್ಲಿ ಬರ್ಬೋದು, ಎಲ್ಲ ಕಡೆ ಟಾಪಿಕ್ ಬರ್ತದೆ. ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಟಾಪಿಕ್ ಅದ. ಸೊ ವಿ ವಿಲ್ ಸ್ಟಡಿ ವಾಟ್ ಈಸ್ ಹೈಯರ್ ಡೈಮೆನ್ಷನಲ್ ಸೆಗ್ಮೆಂಟ್ ಟ್ರೀಸ್. ಸೊ ಹೈಯರ್ ಡೈಮೆನ್ಷನಲ್ ಸೆಗ್ಮೆಂಟ್ ಟ್ರೀ ಏನದಪ್ಪ ಅಂದ್ರೆ ಹೈಯರ್ ಡೈಮೆನ್ಷನಲ್ ಸೆಗ್ಮೆಂಟ್ ಟ್ರೀ is a multi-dimensional segment tree which is used to solve the geometrical problems efficiently in the form of 2D and 2D and higher dimensions. So in this only saying that higher dimensions. So first we will study about what is higher dimensions. So higher dimensions is like a range which having the multi-dimensionals like rectangles. Examples are rectangles and squares and the dimensions which we are gonna explain in this continue. So first we will it is in the form of normalization. Normalization 1D segment, which is the first segment, and then in the 2D and 3D dimensions. 2D and 3D dimensions. So 1D dimension ಅಂದ್ರೆ 1D dimension ಅಲ್ಲಿ it only having the intervals of a point. So it just can be a single line, or it can be a cross line, or it can be a curve line. So it only having the one point in the 1D segment. So in the 2D segment, it's having the two lines. These are the two perpendicular lines. So if we join these two perpendicular lines, it forms a 2D segment, which is two-dimensional segment. So by intersecting and joining the 2 points, it forms a 2D segment. So same first, and then coming to the 3D segment. So 3D segment ಅಲ್ಲಿ it having a box shape. So ಇದರಲ್ಲಿ ಏನಂತ ಇರ್ತಪ್ಪ ಅಂದ್ರೆ length, having the length, width and the height. It use in spatial data and geospatial data which it ಅಲ್ಲಿ ಇವು ಎರಡು ಯೂಸ್ ಮಾಡ್ತಾವೆ ಇಲ್ಲಿ 3D segment ಅಲ್ಲಿ. So next we will see what is a segment tree. First we study the three basic examples of segment trees. So now we'll study the segment tree. So S theorem, it is having the S theorem. So S theorem is nothing but a segment theorem. So S is a segment theorem. Segment theorem means in higher dimensional segment trees, a segment tree which is used to answer the range queries which are efficiently on the input arrays, which the input arrays we are given. The input arrays can be, it solves the problems of some minimum and maximum of input arrays and the updated input values. So we will now look one example on segment trees. So now one example ನೋಡೋಣ segment trees ಅಲ್ಲಿ. So consider this is the array 1, 3, 5, 7 and 9, 11 are the values of an array. So in the segment trees, first we will draw one tree. Just draw the tree. We will not consider any values. We will add it on last. So this is our tree, and here also one value will become. So this is our root. So we don't know our root. So first we will go with the index values. So index values are the values which are start from here 0, 1, 2, 3, 4, and 5. These are the index values. So with the help of these index values, we will solve this tree. We will solve this tree. So first consider here it from 0 to 0. Here 0 to 1. Here 0 to 2. Here it is 3 to 4. And here 3 to 5. So how we can solve this? First we will just put the leaf nodes. Which are the leaf nodes? Which are the arrays which are already defined. So here it is 1, here it is 3, here it is 5, and here it is 7, here 9, and here 11. These are the leaf nodes which already exist. With the help of this, we will find out the root, and the root should be equals to this sum. The total sum of this is 36. So our root value needs to be 36. So ನಮ್ಮ root value 36 ಇರಬೇಕು. ಸೊ ನಾವು ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ವಿತ್ ನಾವು ಇವೆಲ್ಲ ಸಾಲ್ವ್ ಮಾಡ್ಕೊತಾ ಬರತ್ತಾನೆ ಇಲ್ಲಿ ವ್ಯಾಲ್ಯೂ 36 ಇರ್ಬೇಕು ನಮ್ದು. ಸೊ ಫಸ್ಟ್ ನಾವು ಸಾಲ್ವ್ ಹೆಂಗ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಇಲ್ಲಿ 0 to 0 ಅದಲ್ಲ. ಸೊ ಫಸ್ಟ್ ಇಲ್ಲಿ ಬರ್ಬೇಕಂದ್ರೆ 0 to 1. ಸೊ ಇವು ಎರಡು ಕೌಂಟ್ ಮಾಡ್ರಿ ಎಷ್ಟು ಅಥವಾ 4. ಸೊ 4 ಇವು ಎರಡು ಕೌಂಟ್ ಮಾಡಿದ್ರೆ 4 ಆಗ್ತಾವ. ಸೊ ವಿ ವಿಲ್ ರೈಟ್ ಹಿಯರ್ 4. 4. ನೆಕ್ಸ್ಟ್ here is 0 to 2. 0 to 2 ಎಷ್ಟು 3. More number ಅವ 5, 3 and 1. We plus it will be 9. So you can see here 5 and 4 is 9. Same for here 7 and 9. So 7 and 9. So 3, 4. This both plus. This 4 we plus, we will get 16. ಸೊ 16 ಬಂತಿಲ್ಲಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಏನಪ್ಪ ಅಂದ್ರೆ ಇಲ್ಲಿ ಹೋಗ್ಬೇಕು ನಾವು ಮತ್ತೆ ಪೇರೆಂಟ್ಸಿಗೆ. ಸೊ ಪೇರೆಂಟ್ಸ್ ಅಲ್ಲಿ ಇಲ್ಲ 3, 5. 3 and 5 ಇವು ಮೂರು ಪ್ಲಸ್ ಮಾಡಬೇಕು. ಇವು ಮೂರು ಪ್ಲಸ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಎಷ್ಟು ಸಿಗ್ತದ 27 ಸಿಗ್ತದೆ. 27. So we will get 27 and then in final we will get it as 36 with both adding. 36 our root. So the sum of array is 36 and the root value is 36. Root value is 36. So here these are the leaf nodes. These are the leaf nodes. These are all the leaf nodes and these are the internal rows which we sorted. So here leaf nodes are the bottom of leaf nodes which used to solve the sum of an array, and these are the internal nodes which it used to solve by the inputting arrays from the given sum of two or more elements by adding two or more elements, and these are the root node which is used to present all the values of some of the root node, some of the array tables of the segment trees. And next we will, so in this it's having the time complexity of 0 order of n. It's having the order of n. It's having the sum of all the elements from the building blocks. It's considering all the table. And next why the segment tree is most important, because the segment tree solves the sum of queries from all the elements. So it is very easy and better compared to the another segment trees. Thank you.